Anyway, the next segment that we're going to be covering are basic electronics and the components that are used in basic electronics. There are generally two types of electronic component: active and passive. Active component either provides or amplifies power. So an active component, yes, for active components, provides or amplifies power, such as batteries, solar cells, a wall socket, generator. Another component that we'll be looking at in a little bit of detail later on, a transistor. Is an active component. Passive components absorb power. Most of the components that you're going to be using are going to be passive components. That includes switches, resistors, capacitors, inductors, transformers, diodes and LEDs, now we get into integrated circuits can have both. They can be both active and passive, depending on the type of component that your integrated circuit that you're using. There's quite a wide variety of integrated circuits that are available. You'll get into learning basic logic functions in digital logic if you haven't taken it already. But there are two general categories of electronic component, active and passive. Think of active as being activating the circuit, like a battery or a solar cell or a generator. Transistors can be used in amplifying signals. So they are an active component as well. Now, the first component that we're going to cover is resistors. And that's a passive. They are characterized by their resistance, which is in ohms. Which is, the symbol is the uppercase omega Greek letter. They resist the flow of current. They are used to reduce current flow, divide voltage, adjust signal levels, and bias transistors. Oh, I forgot one thing they're also characterized by is power absorbed. Which is measured in watts. Can't forget that. Now, the symbol for a resistor, a schematic symbol, is a squiggly line. There are variable resistors that have the zigzag line with an arrow pointing toward the middle of it. This is a resistor. This is a variable resistor. Also called a potentiometer. Between a variable resistor and potentiometer? A fixed resistor has a fixed resistance, again in ohms, whereas a variable resistor, you can vary the resistance across a range. Yeah.
So would you call it a fixed resistor?
Just a resistor. You could be more specific and say fixed resistor, but yeah, just a resistor. Now there's a law called Ohm's law that characterizes or shows the relationship between voltage, current flow, and the resistance of the resistor. Everybody got this, or still getting there? The last one? Integrated circuits can be either active or passive. Yeah. Got it? All right. So when analyzing a circuit, you have Ohm's law, which is V equals I R, which is voltage across the resistor, the current, and the resistance. In ohms, current in amps, and voltage in volts. Now it is important that you remember Ohm's law. You'll use it a lot. How I remember it is that it's named after a fellow named Ohm. And as it happens, VIR spells man in Latin. So it's named after man. Man is in Latin is the equation, V equals IR. Kind of a silly way to remember it, but it works for me. But it can be solved for in various different ways. I equals V over R, and R equals V over I. Those I have to work out in my head every time. I don't have a mnemonic for those. But those constitute Ohm's law. So if you are looking to put a certain amount of current through a resistor or through a component, and you need to control the current with a current limiting resistor, you would take the voltage of the that you're passing through, divide it by the current that you want to give it, and you'll get the resistance of the resistor that you need to place in the circuit to limit the current to that level. Likewise, you can measure the resistance of a circuit divided by the voltage of the circuit and get the amount of current that the circuit uses. But very important to remember that Ohm's law. You will use it a lot. Now, related to that is the power dissipation. Is that one S or two S's? I don't know. It doesn't matter. Now, we learned from before that power equals VI, right? So substituting that into Ohm's law, we get, for example, P equals V squared over R, right? Yeah. And also P equals I squared R. Because if you solve for I, P over V equals I, and then substitute that into V equals P over V R into Ohm's law, and then solve for P, you get V squared equals P R over R, and P equals V squared over R. Same sort of situation with solving for V and then substituting V into P over I equals V. Substitute that into Ohm's law. It's P over I equals I R, and then P equals I squared R. Just a little bit of simple algebra to get those various forms. It just depends on what you're trying to solve for and what information you have available. I'm sorry? Yeah, it cancels out. This cancels out. So it's V squared equals, oh yeah, V squared. You divide by R on both sides and you get V squared over R equals P. So, I mean, no, cancel. Let me do this again here. P equals, come on, V squared over R. And you can use that to calculate power of a system by the resistance that it uses, divided into the amount of voltage it uses, and that gives you the power. V squared over R equals P, yes. Yeah, it's the same as this. Yeah. And so if you have, say, 100 volts going through a 1,000 ohm resistor, the power would be, what would that be? 100 watts. If you a resistor that is 100 ohms, 100 volts, yeah, it would be a 100 watt power dissipation on the resistor. In that particular example, that would be like an old incandescent light bulb. Dissipates 100 watts. That's why they generated so much heat. 100 watts is quite a bit of power. Now we have LED lights that use considerably less power and generate light without so much heat. But, let's see here. I think I'll save capacitors for another day. But a lot to chew on for resistors. This is where most of the equations are going to be at. Oh, I forgot one little thing. Resistors in parallel and series. So say you have a resistor and another resistor, R1, R2, R total equals R1 plus R2. Pretty simple and straightforward. Yeah, what you would expect. Where it gets a little bit more mathy is that when you have R1 and R2, let's see here. Let's see if I'm remembering my math right. It's 1 over R1 plus 1 over R2. If I am remembering correctly. Who's here's taken circuits? Is that right? Yeah, okay. I'm just trying to remember that off the top of my head. But it's a little bit more mathy and to calculate resistors in parallel, but those are the two configurations that you can have, really, and various permutations of those, various combinations. But I think if I go any further and deeper into resistors, I'd be treading on circuit theories class content. But that about sums it up for resistors. And I guess I'll call it a day after that.